So we continue with our modes of heat transfer, and we'll try to wrap up the other two modes, convection and radiation. Pretty nice discussion. Again, theory. We don't have any numericals out here. So enjoy the theory and enjoy the discussion. We last covered about conduction. Conduction was, what was conduction? Conduction is a mode of heat transfer in solids without motion of the matter in which heat is, the matter in which you are the heat is getting transferred, that particular matter is not in motion. What is in motion is only the particles. Okay, so without any motion of that particular piece of matter, you transfer heat from one part to other part. Conduction is seen only in solids, solids and solids. And in conduction, we call that those who conduct heat are known as conductors. And this happens due to free electrons. I'm just trying to recollect what we studied. It happens due to free electrons. If you don't have free electrons, you will not support conduction. That's the reason insulators don't support conduction, because insulators don't have free electrons in them. And another form of heat transfer can be there, which is due to lattice vibration. Remember lattice vibration, in which the whole lattice gets heated up. But that mode of heat transfer is much, much less. So the one which is more responsible is free electrons. This is what we have studied. Today we go to the second mode of heat transfer, and that heat transfer is known as convection. Okay, we go for convection. Now, convection is the mode of heat transfer that is usually seen in liquids as well as in gases. So pretty briefly, we'll try to understand. As I gave you one example of, water getting heated in a saucepan, and that is a lovely example which can actually make you understand what is a conductor, what is an insulator, what is conduction, what is convection, and even what is radiation. So today we take the same example, and we will be concentrating only on the water getting heated up part, not on the other things. Okay, we'll be concentrating how water is getting heated up. So this, and we are supplying heat from here. So we have got water out here, and water is a liquid. Now how does the water get heated up? So if you are heating water in a saucepan, you can try and do this also. If you initially dip your fingers out here, you will not feel anything hot at the top surface, because the water gets heated up from the bottom, right? नीचे से पानी गर्म होता है, ऊपर से गर्म नहीं होता है. So how does the water get heated up? So whenever the bottom portion, let me just start coloring it. So let's say we have these, the bottom portion. The bottom portion of the liquid first senses the heat, and as soon as you apply heat, okay, this will be a universal. So as soon as we apply heat, if you supply heat, then whatever substance is there, substance means in our case liquid, our substance will expand, and if a substance expands, then the volume increases. Sorry, 1 minute. Then the volume increases, and if the volume increases, then the density decreases. Is this logic understood or not? Just see. Density क्या होता है बेटा? Density is always equal to mass upon volume. So अगर आपका volume बढ़ जाएगा, the density is going to fall. So you started heating this liquid. The green portion of the liquid got heated. So the green portion starts expanding. As it starts expanding, its volume will increase. If the volume increases, the density falls, right? And if density falls, what happens? Substance becomes light. So these green, जो green particle है, they will start going to the top surface. ये समझ में आया? They will go to the top surface. And what they will do, whichever heavier particles were there at the top one, the heavier ones will be now pushed below. समझ में आ रहा है? Heavier ones get pushed below. And as the heavier ones get pushed below, the heavier ones start getting heated. Again, they become light. They go to the top. Again, they push the ones who are less lighter than them right below. So what happens? A sort of, ये एक तरह का, a current starts developing. Current means current, and this current is known as convection current. When this current ceases to flow, when will it cease to flow? When all the particles attain the same velocity. It's not same velocity, same temperature or same heat. Once you have attained the same heat, who is lighter, who is heavier? Everyone is at the same level. Everyone has expanded to the same level, right? So you can't say somebody is light and somebody is heavy. So the temperature starts becoming constant. This is the idea in which liquids start getting heated. So what is convection? Convection is a mode of heat transfer which is seen in liquids and gases. So as we start heating liquid, the lower layer of the liquid which is in contact with the heat surface first will get heated up. As it gets heated up, it starts expanding. If it expands, its volume expands. If the volume expands, the density falls. If the density falls, object becomes lighter. What is the idea of flotation? I hope you know that. Floating can happen only when an object of higher density is the medium on which an object of low density floats. This is the funda of floating. Do you know that or not? ठीक है, कोई भी चीज जिसका डेंसिटी कम है, that only can float. So therefore I always say Uranus density is less than that of water. If somebody could have brought Uranus on Earth, which is not possible, Uranus is much bigger than Earth, and dropped it in front of the lake in Piramcheru, Uranus would have floated on Piramcheru, because Uranus ka jo density, Uranus is a planet made only of gases. So Uranus's density is less than the density of water. So if Uranus was thought to be a ball, and if somebody would have dropped it on a river, Uranus would be floating. यही वाला concept है. Floating के लिए, so this thing goes up. Same thing happens. Now this is how water is getting heated up. Now this convection current is set up once you start heating a liquid, and the convection current ceases. The current ceases to flow when the temperature across all the layers have become uniform. Are you understanding this? थोड़ी थोड़ी बात, पहले गरम ऊपर गया, नीचे फेंकला, नीचे वाला गरम हुआ ऊपर गया, ऐसे करते करते everyone talks to each other. Hey, we are all at the same temperature now. Now nobody is light and nobody is heavier as compared to one another. The temperature has become constant. Have you understood this? This is called convection in liquids. इसका proof अगर किसी को भी चाहिए, so what you do, you take water, and at your home, food color, if you have got habituated to a little bit of cooking or something, or say food color float karega. Let's take potassium permanganate is the best thing. Take one crystal, small crystal of potassium permanganate, and you drop it out here. You will see a nice trace of potassium permanganate going from bottom to top. जो कि आपको, and what does potassium permanganate do? Chapter 1 we read diffusion. Diffusion. Temperature always increases diffusion. Yes or no? The rate of diffusion increases when there is a temperature difference. नीचे वाले घर ने अगर बिरयानी बनाया है तो हमें खुशबू अपने आप आएगी. So potassium permanganate gets mixed up. Why? Due to diffusion. Now here there is, the temperature is right below the vessel. Due to this temperature, the potassium permanganate crystals will start diffusing. Our idea was not to study diffusion out here. Our idea here was to study that it is how the heat flows from the lower layer to the top layer. So you will see the rate of diffusion slowly more out here. यहाँ देते ही potassium permanganate will start leaving its trace, just like some magic is going on. Is this clear? ठीक है? Then there is some instrument. Your book also talks about one instrument called lava lamp. I don't know how many of you have seen it. During our childhood, this used to be a decoration piece in many people's house. ये lava lamp कैसा होता है? Is something like a trapezoidal sort of a decorative item, and this portion is all of glass, see-through glass, and this portion is opaque. Basically here there is a bulb. ये bulb जलता है तो ये गर्म हो जाता है, and in this opaque crystals, this transparent glass, this will be some colored red or colored blue. People used to keep it in the drawing room. You know, these there's a sequin chumkis and all we have, na? Light mica particles will be dropped out here. So when you switch it on in the evening and you make your room dark, then slowly the water gets heated up. As the water gets heated up, these mica particles ये lava lamp में ऐसे lava जैसा flow करते रहता है. अगर फिर ठंडा कर देंगे. Another thing that proves you the convection current setup in liquid. Have we understood this? Any questions so far? अभी हम convection in gases में देखेंगे. So what is convection? Another mode of heat transfer. In this mode of heat transfer, it does not happen in solids at all. Solids में heat transfer happens only due to conduction. Convection is a mode of heat transfer which is seen only in liquids and gases. Are they due to that inside the particle and free electrons? No. Those are all in conduction. In convection, the mode of heat transfer is due to the convection current that has been set up. What is a current? Current means whenever there is a flow of some sort of a parameter. Electricity current flow करता है. उसी तरह यहाँ क्या flow कर रहा है? Heat flow कर रहा है. Lower portion will get heated first. It will expand. Volume increases, becomes light, goes up. ऊपर वाले को नीचे धकेल देता है. और ये करंट का कंडीशन चलना शुरू हो जाता है. So I think we know now what is convection, we know what is convection current also. Same sort of concept we will now see the effect of convection in air. Okay, let's see the convection. This is a very small geography question which you used to do at a very what do you call kilo level classes. Convection in air. And people who have gone to sea beaches typically as we explain, I'll let you know. So let's say this is a typical area of a beach, and let's say this is land. ये हमारा land है, and this is sea. Okay, this is sea. This is sea. We'll see this scenario under two circumstances. This is day. Okay, during the day, as the sun is shining bright, गर्मी बढ़ना शुरू हो जाता है. So one thing always holds true. ये remember रखिए, land gets heated quickly, okay, and cooled quickly. Always remember this. Cooled quickly as compared to water. Can you explain me why this happens? You actually have studied this. इसका जो पीछे का ज्ञान है, that you have studied. Land गर्म होने में टाइम लेगा, ठंडा भी हो जाएगा जल्दी जल्दी. Sorry, lands get heated quickly. Land गर्म जल्दी होगा, ठंडा भी जल्दी होगा. This is the problem in Cambridge. They will ask, see, you actually, I don't say that you don't know, you know. आप ऐसे hit and trial कर करके मुझे आंसर भी दे दोगे, मैं जानता हूं that inside your tummy you know, but what is missing in your lips, you know, the perfect word, specific heat. ये word अगर हम आंसर नहीं करेंगे ना, हमें Cambridge नंबर नहीं देगा. That is called the marking scheme. Imagine this is the hot water bag. My mother, why does she take a hot water bag? She takes a hot water bag because she wants compaction. She wants the heat to be preserved. So she uses boiling water inside that bag. Water एक ऐसा चीज है, गर्म होने में टाइम लेता है. क्यों टाइम लेता है? क्योंकि वो हीट पिए जा रहा है, पिए जा रहा है. What is specific heat? Amount of heat required to raise the temperature of 1 kg of a body by 1 degree centigrade. Water 1 kg in the hot water bag of my mother. How much water will be there? 2 kg water. 2 kg water पानी पिए जा रहा है, हम लोग गर्म बिठा दिए हैं. Once that water has got heated, it loses heat also very slowly. So सारा रात उस लेडी को काम में आएगा. She can put it on her pain joint and she can sleep. Rather she would have used something else than water. अगर हम alcohol को गर्म करके दे देते ना, alcohol would have heated up and cooled also quickly. Specific heat. So here whose specific heat is more? Water specific heat. Water always remember, water can go on and go on and go on eating. How much is the specific heat of water? 4200 joules per kg degree centigrade. ठीक है ना? इसको इतना सोचने की जरूरत नहीं है. 1 calorie is equal to 4.18 joules. ये वहीं से आता है. The exact definition is 4180. We take it as 4200. That 4200 has come from 4180. So water can eat up 1 kg of water can eat heat worth how much? 4200 joules. Then only the temperature of water will increase by 1 degree centigrade, provided the pressure remains same as the atmospheric pressure. And in my kitchen, when I'm heating that water for our hot water bag, the pressure is 1 atmosphere only. We can't change the pressure. So every degree that you are trying to increase the temperature of that water for our hot water bag, how much of joules is it eating? 4200. And the release is much slow. If we would have made our hot water bag, instead of hot water bag, we would have made it hot land bag filled with earth and mass. सोचो ना कितना मजेदार है. Land gets heated quickly. It would have heated very quickly, but it would have also cooled quickly. That is the reason, like in earlier days when people used to play and all, and used to get sprain and all, so we used to have these fire kitchens inside the kitchen. I'm talking even one generation before me. People used to take cloth and put it on that, what do you call it, indigenous chula, and take that heat and put it on your body. After some time, the cloth again loses its temperature. फिर उसको गर्म बिठाएगा, फिर लगेगा, सेक देते बोलते हैं ना दर्द होने से। लेकिन पानी में ऐसा नहीं है, पानी का बैग आप लगा के रख दो, पानी ठंडा नहीं होगा, बहुत टाइम लेगा। ये चीज समझ में आया? ये ज्योग्राफी में भी आपको हेल्प करेगा। लैंड ऑलवेज गेट्स हीटेड क्विकली एंड कूल्ड क्विकली। सो लेट्स से दिस इज मरीना बीच इन चेन्नई। As the sun shines during the morning, what will happen? The land will get heated very quickly. The water will take time to heat, but it doesn't mean the water will not heat. The water will also heat up. By evening, what will happen? The land will cool down because the source of heat is gone. पानी जो है वो गर्म ही रहेगा। इसलिए अर्ली मॉर्निंग अगर आप स्विमिंग पूल में डूब मार दोगे ना, आपको लगेगा कि स्विमिंग पूल पानी ठंडा है, स्विमिंग पूल पानी ठंडा रहेगा, दिन बढ़ते बढ़ते पानी गर्म होता है। ठीक है, तो अब देखते हैं। सो ड्यूरिंग द डे टाइम द लैंड गेट्स हीटेड क्विकली। सो एज द लैंड इज गॉट हीटेड quickly, so what happens? Land is a hot zone now, so all the hot air from the land has started to rise up. Why? Because these air have now become what? Lighter. They have expanded, and this is what? This is my hot air. The hot air rises up. ये hot air rise up हो गया, और जैसे ही hot air rise up हो गया है, क्या होता है? Cold air from the water, because the water is still cold. Yes or no? The cold air from the water, this is cold air, it immediately starts to fill this place. This is what is known as, इसको क्या बोलते हैं? Sea breeze हो गया आपका, ठीक है? So people who have their houses near the sea beaches will always have doors and windows facing exactly opposite to each other. देखो balcony और ये हमेशा, इसको कहते हैं cross ventilation. This is called cross ventilation. So during the daytime, these people will open their windows. So this is, say, if this is Chennai, then you're facing east, they will open their eastern doors. So cool air will be coming into their house. And the best example is, if you have ever visited, say, why I say Chennai, because it's very common. If you go there and start having a roasted corn at this beach, so the people who have put up the roasted corn stall, you will see that they are putting barricades for their fire on this side during the daytime. But this lady or this gentleman will be doing her business even in the evening. Evening को देखना वही चीज उल्टा साइड में करके बैठा हुआ है। ये डे टाइम का सिस्टम है। Have you understood? Convection of air current. This is called land breeze and sea breeze, as we study in geography. So how does this happen? During the daytime, the land gets heated quickly. As the land has got heated, all the air in and around the land starts to get lighter. They expand and they move up. Cold air from nearby regions starts taking their place. Again, this cold air क्या हो जाएगा? Heat हो जाएगा, वो ऊपर चला जाएगा. Again, another set of cold air will come. So you start forming again what we were discussing, that you start forming what is known as एक current का establishment हो गया. This is one sort of convectional current which is set up. We are not learning it from geography perspective, so we don't call as land breeze, sea breeze. We say convection in air. ये समझ में आया? Clear? ठीक है? अब इसी का ऑपोजिट देखते हैं, इसका ऑपोजिट देखने की कोशिश करते हैं. What will be the opposite of it? So this is my land, and now rather than sun, we have the moon at night, and this is my water. Now use the same phenomenon. Land gets heated quickly and cooled quickly, so the land is now cooler, whereas the sea is hot. So what happens? Hot air from the sea will be rising up. ये ऊपर चला जाना शुरू करेगा. These rise up, right? And cold air from the land will be actually flowing towards this. ये cold air, it's cold air, right? And this is hot air. So if you again see out here, we will be setting up another convection current setup. That's why people who have their houses near sea, they will always have one sort of breeze always flowing. दिन में sea breeze, रात को लैंड ब्रीज. रात को उल्टा हो जाएगा, इस साइड के दरवाजे खोलेंगे, इट विल गो आउट. ठीक है? दिस इज इन कोस्टल एरिया. इन नॉर्मल हाउसेस, हाउ आर आवर नॉर्मल हाउसेस डिजाइन्ड? Our normal houses are always designed in such a way that if this is the front elevation of the house, you will have the doors out here, the windows will be always at the door level, and the ventilators will be always at the top, which means hot air rises up, so all the hot air will get out from the ventilator. Hot air कहाँ से निकलेगा बेटा? Hot air यहाँ से निकलना शुरू हो जाएगा, and cold air will be getting inside the house, and all the cool air getting from here. Have you observed any sort of a furnace or any sort of like heated element? It can be like a if you go to cold places, you have got fireplaces, another thing. Write the area above the fireplace or the area above a hot blower or something. On that ceiling, you will always see dark patch happening. That's because hot air rises up, all the dust particles have been taken by the hot air, and that's why anything that is hot, उसके ऊपर में आपको हमेशा dark patch दिखना शुरू हो जाता है, which if you start brooming and dusting will get away. But the question was, why did this dust accumulate here only? Why not any other way? That's because the hot air went in this direction. So there is an experiment in your book also. What they do, they take two tumblers. Okay, they have this experiment can also tell you the same thing. They have a wooden block. In this wooden block, they will be actually making two holes, and two tumblers will be kept, glass tumblers. Okay, and through this tumbler, they will keep a hot source. So you should kept a candle out here. So hot air will rise up. Now you can't see the air. So what they do, they take a brown paper and they dip it in potassium nitrate, KNO3. Brown paper, if dipped in, or wet brown paper dipped in potassium nitrate, mein dip kar dene se, you can see the direction of the fumes. The fumes can be seen. You will actually see fumes getting in from this side and getting out from this side, because this was the hot zone. Are you understanding? This is the hot zone. Hot zone se gases will go up and cold zone yahan se ghusega, convection current. So is convection clear? इसमें और कुछ है ही नहीं, book में you just have this much. So if there is a difference between two terrains, where there is a temperature difference between two terrains, if you get a temperature difference, then you can always have a convection current setup. And that is how gliders use it. Hand gliders जो रहता है ना, gliders कैसे glide करते हैं? A glider, अब आप सोचो glider कैसा glide करना चाहिए? A glider can glide only as long as he travels from one thermal to another thermal. You know what is thermal? Thermal is a region of temperature. Let's say you're trying to glide. I'll say one thermal to another thermal. तो दिन में glider किस साइड में जाएगा? दिन में glider आप देखोगे इस साइड में ज्यादा आने की कोशिश करेगा. यहाँ गर्मी ज्यादा है. Just see, this is one thermal. This is at one temperature level. This is at one temperature level. If you go on coming this side, the temperature is more. The temperature being more and more hot air is rising from air, and more cool breeze is flowing on this side. So if I'm a glider, I'm a guy with the glider, and if I go this side, I will be gliding towards this side. You glide towards areas where you are crossing one thermal zone to another thermal zone. एक zone को हम क्या बोलेंगे? Isothermal. Iso means same. Thermal means temperature. Suppose this is the temperature T. This is at a greater temperature T plus something. Greater temperature T plus something. More and more hot air is rising from here. So more and more cold air is rushing from this place. And as a glider, what do I want? I want a breeze which should make me glide along it. Is this understood? Gliding principle. फेशियल एक्सप्रेशन में तो कुछ नहीं है, इसलिए मैं भी आजकल और डांटता उठता नहीं हूँ. मैं खाली पूछ रहा हूँ, have you understood? If you have not, tell me that if you have not understood. How does a glider glide across? If somebody asks you that question, a glider glide across because it changes from one thermal zone to another thermal zone. And as long as it changes his thermal zone, he is being backed up by a breeze. Why is he backed up by a breeze? He is backed up by a breeze because hot air from the hot zones rise up, cool air from the nearby zone rush to take their place, and that is like a current. That's how it is going. Clear? Or convection में आपका वो hot air balloon. Just think how a hot air balloon rises up. In a hot air balloon, you've got a balloon, then you've got a gas source which is actually burning. So air is getting heated up. जैसे air heat हो जाता है, air becomes lighter. Lighter air means volume is more. Volume more means density falls down. So overall, the density of that whole balloon, basket, and human beings inside it now falls. Lighter it becomes than the air. So ये float करना शुरू करता है. So how is it brought down? Immediately by reducing the temperature. If you reduce the temperature of the air, air becomes cooler. Cooler air means heavier air. Heavier air means density becomes more. तो बस नीचे आना शुरू कर देता है. If you are climbing down very fast, then what should be the safety measure? Put out one parachute. The parachute opens up and makes you glide down. Is convection understood? So in a nutshell, okay, in a nutshell, there are some things that we should know. It says that, is there anything that we left out? No. So you should know some experiments which show convection. One of the experiment was potassium, what you call permanganate crystals which are put in water. As the water gets heated, the potassium permanganate crystals will show their traces, in which you can see that the heat diffusion is happening in the direction towards upside, which shows that the heat is traveling from bottom to top. Lava lamp is one example. And then 2 tumblers kept, in which in one tumbler you are heating the gas, and in other tumbler you are bringing what? A dark brown paper which is dipped in, wet dark brown paper dipped in potassium nitrate solution. As soon as you dip it, you can see the direction of the fume. You'll see cold air getting from this side and hot air climbing out from this side. Then questions may be there, application driven based on land breeze and sea breeze. Is there anything that you have not understood? देख लो. Yeah. हाँ? fume इस साइड से जाएगा ना, फ्लो दिखाई देगा आपको. That's what na, normal air you won't be able to see. But when you bring a brown paper, wet brown paper, and you dip it in potassium nitrate and you keep it here, then the reaction makes fumes to come out of it. तो आपको fumes दिखाई देगा. आपको smoke कैसे दिखाई देता है? Smoke is nothing but a reaction with the atmosphere of the heat. तो आपको smoke दिखाई देता है तो आपको direction पता चलता है ना. The smoke rises up means what? Hot particles are going upwards. So here you will see fumes getting out from this side. That is because of the reaction. This portion you will be holding your brown paper which is wet and soaked in potassium nitrate. उसको यहाँ पे रख देने से जो भी air यहाँ से गुजरेगा, you can see the trace of that air. Are you understanding? Normal air you can't see. That's why you all see, in order to see the direction of flow, you always need an indicator. While heating water, the indicator was potassium permanganate crystal. Here the indicator is the fume. और यहाँ पे तो आप सिर्फ सेंस ही कर सकते हो, आपको आंखों से ही दिखाई देता है. दिन में इस तरफ हवा जाएगा, रात को इस तरफ. लैंड ब्रीज एंड सी ब्रीज. क्लियर?